All right, hello world. We're live. I'm super excited for today's event, joined here by Shirley Wu and Mike Bostock. Hi, Shirley.
Hello.
Hi, Mike.
Hi, Ian.
We have an interesting hour ahead of us. I think there's two big projects that I think we'll spend a minute talking about. If you haven't heard about them, I'm excited for you to hear about it. If you have, you know this is going to be really interesting. And then we have an idea about how to sort of do the two together with some live coding. So that should be pretty cool. So the first thing I want to, the first project is Shirley and Nadi's Data Sketches book. I'm very excited. This is it's a book, but it's also a work.
My copy. I'm only got one out.
Yeah, I mean, it's a work of art, right? It's probably on your coffee table. It's understandable that it's not handy on the bookshelf because it's beautiful to look at. I've got a few Post-it notes here because we've gone through and chosen a few of the is it 24 projects that y'all detailed in here that we want to go over in a little detail today. I don't know, Shirley, do you want to just say a few words about the book and the project in general?
Yeah, so it is 24 projects with 12 topics. So Nadia and I chose 12 different topics, and we each kind of like decided on our own angles for each of them. We went out and collected our own data, did our kind of sketched our own designs, and then we implemented it with code, all with D3 and other libraries on top of that. And then we wrote about the whole process. So this started out as kind of a digital project, online project back in 2016. And we got such good feedback that we were like, let's try making it into a book. Which was a lot easier said than done. And it's taken about 4.5 years to get here, but I'm so happy that it's now out there in the world in book form, and that people are liking it.
Awesome. And I think, one of the coolest thing about both the project and the book is how you detail the process in making all these visualizations. And I think the next project that we're going to be talking about in this stream as well is observable plot, which is a good deal about improving the process of data visualization. So I don't know, Mike, would you like to say a few words about plot?
Well, I'm excited about the framing of this stream because I think it presents kind of a challenge for plot in the sense that I think we have specific visuals in mind. Whereas I think, plot, and we're going to get into this, I'm sure, like at length, I think plot is a tool for exploratory visualization, which to me means, you spend more time kind of thinking about the data that you're working with, the structure of that data, the types of dimensions, and less about sort of a single specific visual form. So in that sense, like, when we'll get into this, like it serves a different purpose than D3. Plot is for fast exploratory visualization where you don't necessarily have a single visualization in mind or an attachment to a specific visual form. You just kind of want to try a lot of things and see what speaks to you and see what's interesting in your data. And the flip side of that is that, if you have a specific form in mind, sometimes it can be harder to do that in plot because it is not going to have all of the controls, the expressiveness, the low level abstraction that you need in order to do that. So I'm interested to see how this goes.
Absolutely.
Me too. And I want to say that I was really surprised and also really excited when Ian kind of proposed this because, like Mike was saying, plot immediately fell into my data exploration phase. But I'm really, really interested in seeing how I can use plot in some parts of my final kind of production coding phase too, of like not using it for kind of my more custom visualizations, but for like the more histograms or bar charts, and kind of putting that alongside with my custom work.
Yeah, I think about it like if you know exactly what you want, like you can start with D3 and have sort of that level of control that you want over it. If you don't know what you want and you're in that stage where you're still kind of figuring things out, you can do that exploration much faster in Plot.
And yeah, one thing I'm interested to get into this as we look at the different projects that we chose to explore is that, Shirley, when we were preparing for this, was telling me how her data exploration process evolved, right? Like, or even the idea of deliberately exploring became like part of your practice, right, Shirley?
Yeah.
So I think that'll be interesting too, as we like then now going back to these data sets, which we know could be turned into really beautiful custom visualizations, seeing what happens when we explore them. So I see, yeah. Shirley, there's two of you. Should I?
Yes,
should
please.
I bring you?
I will leave this one.
We had a little technical difficulty, but I think you're back.
Okay, I'm back.
All right, loud and clear. So while you get set up, if you want to share your screen too, and I can flip over to you at any point.
Yes.
We have basically set up a few notebooks with the data from these projects in each one. And I mean, there's many awesome projects. I encourage you to check them all out if you haven't. But the first one we wanted to look at is this Harry Potter fan fiction. I believe there's, it's interesting, right? Because I mean, sometimes when we're trying to talk about process and like show these things, like this has a lot of properties that are common in all kinds of data sets, right? It's a series over time. You have different categories that you want to care about, like whether the story has different characters in it, whether two characters are together in the story. You have things like how many reviews they got, I remember. So, this is something that we can, we could, I think one thing that might be interesting is to try to make something like this in Plot. But another thing we could do is just, as Mike says, like, how would you start exploring this if you made this today with Plot, right?
Yeah. So I think, which one do you want to start with? Do you want to start with kind of recreating the exploration that I did like years ago? Which, by the way, we had this interesting conversation where we were like kind of looking at my old projects, and I was like, oh, this code sucks. Or like the way I did this really sucks. So I'm glad that there's like an evolution and growth in my process. But did you want to start with kind of how I went about this, and then we can recreate that in Plot, and I can tell you how much time we just saved and cry a little bit? Is that a great place to start?
Well, I mean, the other thing we could think about is, what if we explored a bit and you tell us about the data as we explore?
Yeah.
Okay.
And then,
like, because I was coming in this with fresh eyes, and I've never seen this data before.
Yeah.
And so I was like, what do these things mean, and that sort of thing. And I think that that's the natural part of data exploration. And one of the things that's difficult to do in these retrospectives is to remember like that original state where you don't know anything about this data and how it's structured and like what's interesting about it.
That's a really great point. And considering the fact that it's been 4 years for me, I probably have pretty fresh eyes for this too. So yeah, that'd be great. And yeah, it is probably a data set no one's really seen before, because I'm pretty sure I'm the only person that decided to sit down and scrape Harry Potter fanfiction data. But I see that I think you both already started on looking through it. So yeah.
Yeah, I already fixed a bug in this notebook. like,
Nice.
well, yeah, it was the Safari like date parsing bug. So which you don't
Ah.
notice. So like these, anyway, like if I pull this out, well, so I thought like I put it in a table first or something, right? So like inputs.table, and then so that's the, oops, I typed that wrong. So these are like, this is like a structured object, which is interesting.
Oh.
Right. I had played last night a little bit with just mapping through that original JSON that is from the project. So we can, I see your first move, Mike, is to make a table.
Well, yeah, I was inspecting. Oh yeah,
Here,
so
why
you're
don't
pulling out the,
add you to-
oh, it's my screen now.
It's your screen. Yeah, you ready?
I guess I was. Yeah, so like this is coming from JSON, so it's not like a CSV where there's just an array of objects and then each object has some number of properties, and all those properties are typically primitive, like strings or numbers or booleans or dates. Like in this case, you've got a title as an object.
Yeah, so this is why when I was looking through my old data, I was roasting my own data as I went through it, because this was in the days when I, for some reason, decided to make everything JSON and store it that way. I think it was because some of the things like genres, there would be multiple genres.
Yeah.
And so then instead of having them be comma separated, I just had them in an array so that they would be easier to read in with my JavaScript code. But it's interesting to see how that interacts with kind of the observable tables and like the way that people that actually have experience with data read in data and work with it.
The table, I think, is a little bit assuming you're giving it the CSV stuff. So what it does is basically toString the fields. And if you have an object here, so if I pull out like the first thing, and a title, it's this object with a link property and a text property. But if I just toString it, then I get this thing that's not very useful. So what I think Ian set this up here is like kind of flattening it out and also like changing the types. So one of the things that's frustrating about JSON data is that it doesn't have any date representation in it like JavaScript. So dates are always represented as strings. And so we have to convert those into date objects. There are some other like nuances, like it doesn't have undefined as well. Like you can only do null. And then, so I think in this case, like one thing we're doing is like we're pulling out the text field from the title object and this link field, and then the text field from the author. So if I switch that to data, then you get something that's more reasonable because we're now flattening it out.
So should we make that into the HPPF and then
Oh, I think it's fine to have like two things. You could combine them into one cell, but as long as we remember to refer to data and not HPFF.
Oh, yes.
Fine.
Yeah.
What else?
Okay.
Oh yeah, and like here's another one. Like this reviews object has a text field, and this 42 is a string rather than a number. And like, this is not very interesting from a visualization perspective, and we probably like bored the entire audience here, but also like it is super important, I think, from an actual truthful representation of this process here. Like this is 80% of the work is like understanding the messiness and the structure of your data. We haven't even gotten into yet kind of the meaning. I mean, we are touching on the meaning here. Like, what is this? Do you remember what this reviews?
Oh, yeah. So I think maybe I should explain this data set, like back up and explain this data set a little bit more. But this data set there is a fan fiction website dedicated to Harry Potter called harrypotterfanfiction.com, where I spent quite a few of my teenage years. And this topic was called nostalgia. So I decided to go and scrape every single story from that website. And reviews is the number of, so each row is a story, and reviews is the number of comments, essentially, that story got. So the more reviews, it means that the more popular the story was. I'm also realizing that I'm just kind of like revealing a pretty embarrassing part of my teenage years on the internet. But yeah, so then there's also genres.
Because of Harry Potter. I've been to Harry Potter World.
No, I don't think Harry Potter part is embarrassing. I think the fact that I was reading fan fiction is the part. Like I was
That's the
so
bridge too
into
far.
I was so into Harry Potter that I needed more, and I went to fan fiction. I think that's the part that's embarrassing. Anyway, so yeah, there's genres, and then I should explain some of the others. So. Genres, I think, is self-explanatory. Characters is all of the different characters that appear in the story. Pairings is if it's like romance, then the main characters that are paired, and then publish, date, and then the year. And I think, yeah. So then from there, for example, even now, if I kind of like forget how I went about the analysis and exploration, and even now, if I think about what I'm interested in, I think the most interesting part is the reviews, because that's the popularity of the story. And I think also the interesting part to me is like, who are the characters that are the most written about, and then who are they paired the most often about? So I think reviews, characters, pairings, genres is kind of interesting also. So those are probably the places I would head to first. And then I would probably look at when each story is published.
Sorted the table by reviews so you can get a sense of like what the extent of that column is. Have you read this one?
Sorry, what?
Delicate?
Have I read?
Yeah, this one. This is like the most reviewed Harry Potter fan fiction, like Still Delicate by Padfoot Forever.
Oh yeah, I've read that one. But
that's Sirius Black, right? Padfoot. That's like his.
Yeah.
His code name is.
I think so. Oh man, it's been a while. My favorite part of this project was digging into the. So eventually, spoiler alert, I found that there was a correlation between the pairings and the genres. So like certain pairings leaned heavier towards certain genres. Like if you have there's a pairing that's Draco Hermione, and they lean super hard towards angst. And then some of the titles in that is so hilarious. Anyways.
So can we try like doing a couple of those things? Like one thing that occurs to me is like doing a histogram of reviews to get sort of a sense of like what the range is, like how many have a lot of reviews, how many have no reviews, and that sort of thing.
That sounds great. Should I try that, or should we watch you do it? I'll give it a try. So actually, before I even get there, I'm going to write down what it is that I want to do. So we're trying to look at a histogram of reviews. So to do
Shirley, sorry, I'd like to switch to your screen, but it looks like you're sharing.
Am I sharing the wrong?
The wrong.
Wait, really? My bad.
I'm right. Yeah, we're still on Mike's window right now.
Okay, so window. There we go.
Okay, there we go.
Awesome. Okay, so to do that, I want a mark that is a bar, I think. Ooh, let me open up the plot documentation. Just in case.
Well, I was going to do something that's like a little simpler to start.
Ooh,
which is basically like just plot all of them. So, you can put in what is it called? A rule X or something like that, which is your data. And then X is reviews. And so that basically like draws a line for every row in this data set.
Mm-hmm.
And so you can kind of tell already like how it's clustered.
Ooh, this is, I think, still delicate over here.
Yeah, exactly. And then if I make some, I don't know if I can do like stroke opacity. I don't even remember. Yeah, there we go. You can have it kind of fade out. So it's definitely like one of these like log normal or, Zipfian distributions where like there's a long, most of them have very few reviews. Mm-hmm. And then there's a few at the top that attract like most of the attention. So we're probably going to see like just one of those single bars or something like that at the top.
Yeah. So I'm gonna now attempt this. So I think I want to, for a histogram, I think I want a rectangle or a bar. Is it a
that's
bar?
Right. So again, like we want to think about the data. And this is like, I think something that often trips people up working with Plot, where you're kind of thinking about the visual form rather than the data form. And Plot is going to try to force you to think about the data form first. Mm-hmm. So when you think visually about a histogram, you think like, oh, there are bars there, right? Like it looks like a bar chart. I'm drawing these rectangles that are going up from the x-axis, and they encode length or something. Their length encodes some quantitative value. The difference though is that Plot has both bars and recs, and the difference between those two things depends on the type of that dimension along the x-axis in this case. So if you have ordinal data, which would be like names or colors or countries or sizes of coffee, I think, like, or t-shirts, like small, medium, large, or pizza, that sort of thing. You use a bar. If you have quantitative data, which in this case we do because these are counts of reviews, they're numbers. So then we're going to use a rect. And then the other thing that goes along with that is like the group transform versus the bin transform. So bar is to group as rect is to bin. And there's some discussion about like trying to unify some of these things, which may be possible. But in this case, because we are going to be taking this quantitative dimension, this review count, and turning it into something that's discrete, like a small number of bins, we're going to use the bin transform rather than the group transform. Yeah, but actually, the next cool thing is that there's no. Sorry, I got ahead of myself. I don't think we can actually there's some other like tricks that you can do here. Like there's an implicit group transform, an implicit stack transform. Anyway, I'm just rambling at this point. So let's see.
Wait, can I just because I feel like you dropped a lot of wisdom in like 2 minutes. So can I just summarize in my own understanding real quick? So, and then I have some follow-up questions too. So the part where you said bar is for ordinal data and rect is for quantitative data, that makes sense to me because my understanding is that bar only has scale in one direction. And so if you have something discrete, so if you have something discrete in the X direction, then it makes sense that like for the bar, the X direction is fixed. And then the Y direction is where you have kind of the scale.
Yeah. I mean, both bars and recs have at least two dimensions in the sense that they both have an X and a Y. Mm-hmm. The difference is, this is like, what do they call it, right? You have the dependent variable and the independent variable, right? Mm-hmm. So like if you're plotting, time is your independent variable, and then the dependent variable is like, the temperature or something like that for a normal time series. So there are, in addition to like bars versus recs, there's two orientations of those, which is like bar X and bar Y, and rect X and rect Y. And so, for bar Y and for rect Y, they both grow up from the X-axis. So the length, the quantity that they're encoding is in the Y dimension, which is why it's in the name, although it's just a little bit of an arbitrary convention. Like you're sort of representing the orientation of that. So that's what I think of as kind of the primary dimension of vertical bars is the Y-axis. And for a horizontal bar chart, it would be bar X. So the primary dimension is quantitative. but the secondary dimension for bar is going to be ordinal.
I see.
And then for rect, like both dimensions are quantitative, but it's still interesting because there's actually like, there's 3 dimensions or 3 quantitative values that are associated with a rect. But I think it'd be best like to sort of show it.
Okay. Sounds great. Okay, so when I was thinking about this, so the data, like you said, is the reviews is quantitative. And then this is the part I was like, this is really interesting because the reviews is quantitative, but then we were going to bin it. So that's why I thought it would be a bar, because once it's binned, it is technically
right.
discrete.
Well, but discrete and ordinal are slightly different in the sense that like with discrete, the idea is like you just have a few countable things. You're discretizing some quantitative space. I mean, it's still, one way to think about it is that like ordinal, like quantitative data is still ordinal, right? So ordinal literally means like you can order the data, right? Like you can say that one thing is bigger than another thing. Whereas quantitative is saying that you can actually quantify the distance between 2 things, like you can subtract 2 values. So if you have something that's 10 and something that's 5, that's quantitative because you can say 10 minus 5 equals 5. On the other hand, if you have ordinal data like medium versus small, you can say that medium is bigger than small, but you can't really say medium minus small. There's no value in that dimension that is expressible to represent the difference between medium and small, unless you can sort of upgrade that ordinal data into something that's quantitative, right? Like if you know that medium is 16 ounces and small is 12 ounces, then you can, now quantitative, and now you can sort of turn it into something quantitative. So when we discretize something that's quantitative, it's still quantitative, but we are sort of just looking at specific values in that quantitative dimension rather than all values of it. Whereas when we're working with ordinal data, like it's like you still just have ordinal data and you're not changing the nature of it, if that makes sense.
Yes, that made a lot of sense. Thank you for teaching me. Because I don't think I ever understood the nuance of that. So that makes sense why then each bar should be a rect Y. And then for each of those, I want to group them by the X dimension. And when I'm grouping, I think I wanted to say that it's by, I want to count them. And so do I say it's an object and a type count? Was that how that worked?
Well, so I think that, the easiest thing to do, and this is your screen now, but we can bring up the documentation or something like that. But I can also play the role of GitHub Copilot here and tell you what to do. So there's the first thing I did is per our discussion, change this to bin. Then group. And then, so there's 2 arguments here, if I recall correctly, right? There's the outputs and there's the inputs or options. I guess if I want to write that full. So basically, you have the way to so bin is a transform. And in plot, what that means is, you have some data, some tabular data set as your input, and then you're going to derive new data as the output. And that data is then going to be passed to your mark here. One thing we could do, just to kind of show what's going on here is to write the kind of equivalent thing in D3, which is this bin operator. And I'm actually, then I would have to remember what the syntax is for the bin operator. But I think it's reviews. We pass in that, and then you can just pass in your data or something. Maybe that works. Yeah. So you can see kind of what's going on here is we have this data set, which is an array of these objects. And then we're using D3 bin, which was formerly called D3 histogram. We're telling it sort of which value of each of those objects we want to use to bin the data. And then it's going to return this array of arrays. So this is the first bin, this is the second bin, the third bin. And then you can actually see what the thresholds are on these these bins, right? So this bin here, number 5, represents the 4 reviews that have more equal to or more than 2,500 reviews, but fewer than 3,000 reviews. So that's these 3 here. And, we can click into it and we can confirm that that's true, right? Like this one has 2,969. And so like the interesting thing is like, you can actually already see basically what we were interested in just by looking at this. Like we didn't even have a visualization per se, but we know that the first bin has 80,542 reviews in it. So it's going to be very, very, very tall, or it's going to span the whole width of our bar. And then the next one is 372. So spoiler alert, like this is going to be basically a single bar histogram.
Yeah.
But this is the nature of things. So we can do the same thing here. Now I think the key thing is, so these inputs are going to be like the equivalent to, this value here that you're passing into the bin operator. So we would say like X is reviews, like that. So because we're binning on X, like the dimension that you were binning on, we're defining what the values are for that dimension.
Got it.
And then for the outputs, I'm pretty sure that we can just leave it undefined and it will
we don't
work,
have to
but
say
I guess
count?
it doesn't. I'm trying to think. Yeah, maybe we do have to say count. Maybe I'm just thinking of like other one. That's interesting.
Oh, so looking at, yeah. Oh.
Yeah, so it's not plotting anything right now, which, actually, so I know what's going on here. It is plotting it. But I think that they're basically invisible because this
A fill?
The number of bins.
no. Because so I think if I set the inset to 0, okay. So this is a sharp edge. Phil and I have talked about this one. So this is a extremely narrow distribution, right? Where we have that one spike at 80,542, and then it just kind of immediately drops off after that. And these ones are basically everything in the first bar is like the fan fiction with almost no reviews in it, right? So these are 42. So you're seeing like all of the things that have no reviews, and then like remember that what was it called? Still delicate.
Yeah.
Still delicate is like way out here, like blowing out the proportion. So this inset thing, when you have fewer bins, it produces like a nice little gap between the rects in your histogram. But in this case, because it kind of fell apart a little bit and tried to generate too many bars, those bars are all way too narrow, and then they ended up just kind of showing nothing. So another thing that we can do here is we can reduce the number of thresholds, right? So this, let's see. So bin uses, I think it's called the Scott's rule by default. Anyway, there's some like heuristic for figuring out sort of the automatic number of bins. But if we put in like 10 or something there, you get fewer bins. And so then you don't need the inset anymore because you don't have really narrow bars, but you just have, like we were saying, one giant bar and then, a bunch of smaller ones. There's another thing that we can do here, which is to sort of crop the data. So like the challenge is like that still delicate is kind of blowing everything out, right? Where you have that one fan fiction with, what was it? 11,000 reviews, and then another one with 8,000 reviews. And so like you're devoting most of your chart space to those two stories, and you don't have any room left for most of your data. So like we can do something else, which is like change and is this how you do it? Oh, this is getting, I think, okay. So I think this is getting a little fancy now, but I'm pretty sure that this is what you do. And set the domain on that channel to be like, I'm only interested in like data or stories that have fewer than, 1,000 reviews or something like that. Yeah.
Oh.
And now you get like sort of a more meaningful plot. And you could even like zoom in farther if you wanted to do like, 0 to 200 or something like that.
Okay, so I have some follow-up questions. First is when I was looking at the documentation, and this might be just like different options. I saw it being the domain thing. I think I saw more like written
Totally.
like this. What's the advantage versus disadvantage of doing either?
So they mean two slightly different things. So, I mean, we can just do both and I can show you.
Okay.
But
Sure.
if I do both, then we get rid of this. And then you can see that there's actually like a bar here that is like goes beyond 200.
Oh.
You see it there?
Yeah.
And we don't kind of need this anymore. Also, that's the same. So what this means is that it's actually like computing all of those bars still.
I see.
For the full data set. But then it's not showing them all because this is defining what the kind of the plot area is, like what the scales are. I mean, this is a scale option rather than a transform option. So the transform is the same. It's still going to compute the bins for the entire data set. It's just that now they're basically like off screen. They're off to the right of the chart. And you could even...
I see.
I think you can actually maybe plot them. I'm forgetting now. I think there's like a style option that you can pass to the top
Like
of
a
the chart.
visibly, like an overflow visible kind of thing, or?
Yeah.
And then you'll be able to see it?
Yeah, I'm wondering if that's an option. Let's see.
That's super interesting. So if, for example, I want to layer
There's
something.
a style here. Okay, so we can do a style on that and say like style overflow visible. Yeah. And so now all of the bars kind of go out there into the distance.
This is awesome to learn. So then does that mean that if I want to layer other marks on top, I would need to do basically, I would have to have the domain on the transform for every single one of those kind of layered marks, potential marks layered on top. Like if I want to like draw, a line through them.
Yeah, right. But the cool thing is you can actually like pull that out into a separate variable. So you don't have to repeat yourself. So you can say like, your const bin is this thing, and then you're returning it.
Awesome.
So now if you wanted to say like plot.line, you would say data bin, and now you're drawing a line on top of it. You can't tell because like they're both black, but we can say like, stroke is red or something like that. And then, stroke width is 3. And now you kind of have that line on top of it.
Brilliant. I have another follow-up question, not about the domains. I'm just basically like, this is my free like classroom today for plot. So this is not plot specific, but this is more just like bins. I never fully understood this part of like what a threshold is. Is this something we should get into? Because I also want to be aware of time because it's not plot specific.
I have an idea about that. I wonder if we could do a histogram of the number of stories over time, like the publish date. Because I think that for me, seeing binning over time like had a sort of visceral like click around that topic. So maybe if we try that, it might cement some of the stuff we've just been doing, as well as giving us a chance to talk about thresholds that are like that are very relatable, like weeks or months, that kind of thing.
I'm hoping that so we did some work on plot that added binning for temporal data. And I hope that that's the current released version of plot, not because we've been working in the version that's in main checked into GitHub, but we'll find out soon enough.
I'm pretty sure it is because that's how I like.
Okay, cool. I'm glad that made the cut. So if we want to do that, I mean, it's basically the same thing we were doing before this thing. And instead of reviews, we're gonna put in whatever the time dimension is. So we can make a new thing
I'll
here.
do it.
Oh yeah, the undefined thing is that's in GitHub, but it hasn't been released yet. That'll be in plot 0.2. That's why I was confused. So what is the time dimension? I guess
I think we can use
here.
published.
Yeah.
Published. Okay. All right. So I'm going to call render, I think it is.
Plot.
Oh, plot. Yeah, sorry. A little big light leaking out there. Cool. That worked.
Nice. So, but yeah, so you're binning, but it's doing something default, right? Like this spans several years. What if we said we wanted to see a yearly bin, right?
Yeah, so there's a few ways we can do that. So I thought, let's see. So like we did before, I can also like show how that works in here. If you say like d.published, and then you pass in the data, we're getting this out here. Let's see, can I pick a small one here? It's a little hard to see like the values at the end. So you can see what's happening here. Like these are numbers again. And so I think the way D3 bin works is that it's always the default implementation, I think, is using D3 ticks, which assumes that your data are numbers. But there's also a new time ticks and UTC ticks method, which is how the time scale sort of decides where to draw its tick marks. But now that's also how plot uses to determine those thresholds. So first, I mean, you can say like, given our data, like what's the extent of this published field, basically, like what's the date range of the entire data? So 2002 to 2016. And then you can put that into like UTC ticks where you want like, 10 ticks or like 20 ticks or something like that. So what this is doing is like, it's like D3 ticks where there's a start and a stop, a minimum and a maximum, and then like the number of ticks that you want to generate. In this case, like we're asking for about 20, and it's going to automatically figure out what the right threshold is.
So I think that was my question, because I'm super used to using ticks, like just passing in dot ticks in D3. And then I never understood dot threshold and when to use either. Yeah.
So I'll show you in the plot arguments, but so like you can see this, like these ticks. So this is using D3 ticks rather than UTC ticks. And the point is like you get these round numbers, which are nice round numbers, but they're not like nice round times. So like if I actually convert them back into dates again, you get these like weird arbitrary times. So that's why we have specific tick generation for time.
I see.
But getting back to like this plot here. So let's see. So what we can do, like we did before with the domain. So we can take, this is our definition of sort of what's getting binned, the published dimension or the published column of our data. And I can sort of like wrap that in an object where now I'm, rather than just passing in it directly as X, which is what you do for a lot of the simpler marks, we're going to pass in an object with a value property, and that lets us pass other options that are specific to this dimension. So that's how we passed in the domain before, where we wanted to kind of constrain which part of the data got binned to focus in on sort of the narrow, the fan fiction with fewer reviews. But we can do the same thing here by passing in like a different number of thresholds or even specific values. So if I do like 10 there, now I get about 10 rects or 10 bars, if you want to use the lax terminology. And so you're passing in this option to the bin transform that lets you control the behavior. But the cool thing about this thresholds argument, I mean, cool depending on your perspective. I think it's cool. I like it. I like the flexibility, but it's also like a little bit of a Swiss Army knife. Like it lets you pass in a whole bunch of different things in there that gives you a lot of flexibility, but it could be a bit overwhelming. So if I go over to this bin transform here, I believe that in here, it will describe sort of this thresholds option. Yeah, and so like I was referencing that like Scott's normal reference rule before as sort of the default behavior of how it figures out how many thresholds to create. And also this like D3 ticks and D3 UTC ticks. But there's a variety of other ways that we can do this as well. So we can give it a name for like one of these heuristics. Like if you want to use the Sturgis formula, you can pass in the string Sturgis. You can do a count. That's what you saw me doing when I passed in 10. We can pass in an array of thresholds, and I'll show you that in a second. You can pass in a time interval, which is probably what you want in this case. Like, you know, if you say you want years, you would say, you know, UTC year there or something like that.
Awesome.
If you wanted to say like every 5 years or something, you could do every 5, you know, and now you're seeing like 2000, 2005, 2010, that sort of thing.
Oh, this is awesome.
So you could also do like, you know, quarters or something like that, like every 3 months or every month. You want to do something like that. So, but, you know, then you see like these bars start getting really narrow and you're actually seeing like some aliasing on the screen in the stream.
Real quick, Mike, someone did ask earlier about changing the width when bars get really thin. Do you mind just like showing how quickly you can do that?
Yeah, so the main thing is like there's an inset. See, why is that? Oh, God, that goes on the outside like that. So by default, you know, you get this inset that provides like a nice 1 pixel gap between bars. The problem is right now, and there may already be some improvements that have checked in. Phil and I have been looking at this. When you get those narrow bars, it's still basically subtracting a pixel from the width of the bar. And so if your bar is, you know, about 1 pixel wide, it just goes away completely and you don't see anything. So you can turn that off by setting the inset to 0. And we'll try to make that smarter so that it doesn't do that for you automatically in the future.
Do you think, Ian, they meant like the width of the whole graph, or being able to specify the width of each bar, and then that automatically sets the width of the graph?
Like, yeah, also being able to stretch the whole graph if you wanted to.
Oh, yeah. Well, there's like, let's see, there's different things we can do. So we can do, what if I get rid of that? So, you know, you can say width or something like that. And now it's like the full width. So here I'm using the shorthand syntax for plot, which is maybe like more confusing than it needs to be. So if I take out this rect, get back to sort of our normal plot here, and I can pass in the marks. So it's the same, it's exactly the same thing. It's just if you're making a plot and you just have kind of one mark that you want to show, you can just call .plot on that mark as a shorthand. Or if you want to, and I actually I have mixed feelings about the shorthand. It is really nice if you know of it and you want the simple cases. But one of the nice things about using the longhand, and the longhand is really only like 8 more characters here. So we're not talking about like D3 style longhand or anything like that. The nice thing about this, I think, is, it's more amenable to, what do you call it? Accrual or like accretion, like adding more layers on top of it. If you want to put that line on top of it, like we were doing before, you already have your marks array. And so you can just do like, plot.line on top of that. But, you do whatever syntax you like, you can do. But the other thing I wanted to show was like explicit thresholds. Right. So if we have this, you can also pass in an array here. Like, I don't remember Do you remember when the last Harry Potter book came out?
2007. I think
2007.
July 2007. I think.
Right. That's good. I didn't know that.
So very.
So what I've done here is like kind of draw a line basically between like stuff that was released before July 2007, and this is like the awkwardness of JavaScript right here. You pass in 0-based month numbers rather than 1-based. So 6 is actually 7, which is July. And then this is 2007. So what you're seeing here is like, and again, we're counting the number of stories here. Mm-hmm. So this is like 30,000 or so, 32,000 before that date, and more than that after that date. Although you can see, like looking at the longer distribution, that like the period of most intense activity, I guess, was around that release of the last book.
Yeah. And I think there was a spike each movie. And that was one of the fun things to learn about this data set is like, and then there's like a holiday spike too, like around Christmas, there's like a lot of people publishing stories.
One thing that I'm just curious about right now is to count the number of reviews over time as well, based on the date that story was published.
Ooh, so actually, this is something that Ian and I were talking about, which is maybe this is a good time to switch into what I had done with D3 that I think is very doable with plot.
Yeah, let's do it. That's the plot that I was matching, which doesn't look too different.
No, this is why we were pretty excited about this one. So what did I do?
Well, yeah, one of the things that you did was like look at the number, and the question you asked early on too is like the characters that stories get written about. And I think that that's potentially a good next thing to try with plot as well, because then
the faceting?
Either faceting or stacking, both.
Yeah, like filtering by genre.
Yeah, so there's genres to break things down, or there's characters, right?
Characters, yeah.
Well, so I actually was thinking it might be fun to pull the reviews in, like Mike said. And the way that I had done the reviews is it's kind of like, I don't know how well I can show this. I guess we can also share the screen. But essentially, it was by, I think, each bin is by month, I think. And then it's kind of stacked every 100 stories. Yeah, I think it's I have a square per 100 stories, and that square is colored by the number of reviews.
Oh yeah, I was just thinking about that. So let's see. Well, one of the ways like a conventional way of sort of plotting that sort of thing would be to do a box plot over time. So the idea is like what you're looking at here is like, what is the distribution of reviews as a function of time, right? Mm-hmm. So the idea is like, was there a golden era of Harry Potter fan fiction where like, most of the great stories, assuming that reviews are a good proxy for quality, like existed in that era. So we can do that. That's not like exactly this sort of thing, but I think is like the more boring approach to that kind of question.
But I think it would be much easier to tell in terms of if our emphasis is on review over time. I think a box plot would be a lot easier for us to be able to see at a glance. Whereas like this is a little bit harder to see the reviews because this is much more about, I wanted to show the quantity over time.
Well, the other thing I think we could do that's like even a simpler starting point is a scatter plot. So if we do a scatter plot, we would say, so these are dots. And then we would say, just like this, basically. So that's going to be X is like when it was published, and then Y is the number of reviews that it got.
So this is something, this is really exciting because this is something that I couldn't think of how to explore back when I did this project. So because back when I was doing this project, I used D3 to explore everything, which I've told Ian this. So my process started with using D3 to explore everything, which took me like a day or two to just like code from scratch the thing. And then I was like, oh, this is really inefficient. And I found Vega Lite. And then after I found Vega Lite, then plot was, and then plot came along. And so that's kind of the progression of my data exploration. But one of the things that I would now feel enabled or empowered to do now that we have plot is I would love to see the intersection of reviews published and updated, because updated is basically how long a story took to complete. And so I think it'd be cool to be able to see like something along the lines of, are there is a story that so usually I think one information I didn't get is like number of chapters. That would be the perfect one if we were like, is the number of chapters correlated with, have a correlation with number of reviews? Like, so more chapters, more reviews. Yeah. I didn't grab that information. So a good proxy is probably like the updated date, like the length of time between publish and update. Does that correlate with number of reviews?
So we can do that.
Sorry, real quick though, Shirley, would you mind republishing the notebook, and I can share the link with people that they can fork, and some people have some ideas on YouTube too. And
just republished.
Somebody asked in chat to do like a log scale on the y-axis, which I don't think will work because there's a lot of values that are 0. So if you get this, like maybe this just is automatically filtering out the ones that have 0 reviews. I'm not sure. But so typically, if you have data that has zeros in it, then you'd want to use, which this one does. So if you plot the log, then you're kind of dropping out all the stories with 0 reviews on it, which potentially could be misleading. So you can use a square root scale or a symlog scale to do that if you want to kind of distort the data. But I generally like, there's a cost associated with using sort of those transforms. Like it adds some complexity to how you interpret the data. So it's always good to start with sort of the more obvious one so that it's easier to interpret. So what were we going to do? We were going to look at the publish versus updated.
Publish, updated, and reviews. So
so
I wonder if that's just a matter of subtracting publish from updated, and then plotting that. Oh, this is exciting.
So that's this. So updated minus published in theory. So that looks sketchy. There's probably something there.
That might actually be. Wait, no. Hold on, never mind.
So we could dig into that. We can also do something like, max of 0 there. Yeah.
I wonder what the negatives were.
Well, we can do that by saying data.filter d.updated is less than d.published. So there's 3 here. Yeah, so these are like the dates are 0, 0.
Oh.
So you got some messy data here.
Yeah.
So I think this is basically like, one of the challenges when you do all this like data cleaning up front, like sometimes like it doesn't go exactly as you expect. So we could kind of try, sorry for the frenetic scrolling here. But let's see. So if I say, go back to our original data, and I would say like, try to pull out this one. So like d.title.text equals unknown story title. That's going to get a bunch of things probably. Okay, only 10 things. And then I would say, and d.author.text is Shirley. So yeah, so see this like updated date, these zeros here. So what we would want to do here, like if we know that this is sort of like how missing data is represented in this data set, one of the ways we can do that is, so when we parse the date here, we could say like d.published equals this, then it's undefined. And do like something like that, or we could fold it into our like parse date function. And now if I go back, so in theory, like I won't need this anymore. So that just goes away. So like whenever you see these like outliers in your chart, like these things that are behaving weirdly, like there's a temptation to kind of want to fix it in the chart itself. Like I said, by doing like the math.max, because that's like sort of where you are. That's the closest to the work that you're already doing. But I think it's generally better to sort of dig into those and try to understand sort of what it represents in your data. Because remember, like plot is encouraging you to think primarily about the type of data, like the metadata, like what do the dimensions mean? How are they formatted? And so when you find something unexpected, like in this case, this malformed date that was just giving us, 0 AD, like, yeah, go back to your kind of cleanup processing step and make sure that that's represented the way that you expect in this case, which would be undefined, or to like, to filter out that data if you don't want to look at it at all. So let's see. So this is like your theory of correlation between like the duration of updated time minus published time to reviews.
Theory incorrect.
Well, yeah, I mean, I don't, there might be something here, but it's hard to tell. I mean, one thing we could do that's like a little bit simpler, I guess, is like so this is currently measuring milliseconds, which is maybe not great. So I think we could convert that to days. I think that's days. It's 86485. So this is like 500 days or something like that.
I love that you have this memorized.
Yeah, wisdom right there. The experience.
Well, let's see. Is that right? So it's like 1,000. That's a second times a minute times an hour times a day. Yeah.
Nice.
645. I mean, you're fixing bugs in D3 time all the time. You start to internalize these things.
I just write that one all out. I did see Ian do something underneath. Was that like a
Oh yeah.
There's a link mark, right? Which you can say like give a start and end point and it'll draw a line between them. And so I just thought, what if we drew a line between the published and the updated and visually get a sense? We're going to change the strip. That's very nice. Yeah, so obviously near the bottom, there's so many low review ones. It's hard to see much signal. But.
Yeah.
Is this one where the log of the Y would make more space?
Yeah, we could try that. So that'd be type symlog or something. Looks like a sunset over the ocean.
Yeah.
Very dark sunset, though.
I mean, this to me is kind of a fun like point about plot, though, is that like it's easy. Sometimes it's just easier to see things than to think about them. Like you get to decide whether you like the visualization after you get it, instead of trying to.
Yeah, instead of trying to code it by hand for 2 days.
Yeah.
And
there was a thought. Go ahead.
Oh, no, I was going to say, and I think that this is the whole point of using plot for, or using anything for exploration, is that I get to see in a few seconds that my theory has no, or my hypothesis has nothing to, like, it's an incorrect hypothesis and I can move on. So yeah, that's all I was going to say.
One of my favorite things about plot, which I think, is maybe obvious in retrospect, or like something that we kind of anticipated, but just viscerally feels different still when you use it, is that, when plot is faster, like when you use a tool that is designed for exploratory visualization, like Vega Lite or Plot or ggplot2 or those other tools, it's not just that you're faster doing the work that you would already be doing. It really changes the work that you do. Like, you see plots that you wouldn't see otherwise because they would just be too much work for you to express them. And that act of seeing them, changes your understanding of the data, changes the direction of your design process, changes the final result in a good way. And so I'm always like, I don't know, I get excited when it doesn't look like what I expect, and I'm like, it still feels like accessible for me to sort of quickly make something and then be surprised by it. Like, that's my moment of delight using plot.
Yeah. And that's what I was saying earlier about feeling empowered right now to do the updated part. Cause that's something that 4 years ago, I have been like, this is too much work to do something from scratch just to explore this. And I also really appreciated what you said earlier about using plot and this like visual exploration phase to suss out incorrect things in the data and using that chance to like clean data. That's one of the like most satisfying part about working with my clients, being like, hey, I was exploring your data and I found something.
Yeah, totally suspect. Yeah, totally. Yeah, it's interesting. Like, I think, and we're doing some work on this, like Mike Freeman had the summary table, and there's some other stuff that we're working on. But, when you're looking at just sort of these first steps, like of just this table, having like a histogram for each of these dimensions so that you see those outliers, like if we're looking at this published and updated column and there was a little histogram that was associated with it, like you see in Trifacta and other tools, you would spot those like discrepancies earlier in your process, like the fact that these dates were like 0 AD. And so kind of continuing to have that good overview as you're going through the different steps, and particularly when you're in kind of the data cleaning and transformation phase, is really important.
Yeah. And kind of to go off of what you said earlier, that like, this is truly the 80% of what we do. Like, I think that the actual part of coding the final visualizations is probably just like, it's the fastest part for me. It's all of this like exploring, cleaning, and then exploring and then cleaning. That is basically majority of my time. The unglamorous part is majority of the time for me making visualizations.
Yeah. I think we're killing my browser here. We've made too many plots on this.
Yeah, I think I'm going to comment out the line ones. The links is like a lot of SVG elements, right?
Okay, so I think it was really cool for me to see the updated part, but maybe we can go back to Mike. I know you had a series of like thought processes that you had, that you were like publish versus reviews. First, let's try scatter plots, and then you were going to try something like, and then you were going to do box plots.
Oh yeah. Well, let me comment out this summary table because I think it's. But this is a good thing to show. Yeah. So like we've already done the data cleaning here. So, but you can at least confirm that like we didn't miss anything else. Like this range is 2002. Well, hopefully we didn't miss anything else. I mean, I'm assuming, I don't know how no, we would have to, right? But we didn't notice that before. Huh. Anyway. So I'm going to comment this out just so the page.
Oh, sorry. Actually, before you do, I just realized something else really interesting from this summary table, which is looking at titles and authors. Author is half of the number of titles, as in like that means each author is writing on average 2 stories. But that will also be an interesting thing to explore if we have the time of like.
Oh yeah, we could do that.
Yeah, like number of, that would be interesting, because then there's going to be like a long tail of authors that have only ever written one story, right? Versus like probably like a few authors at the top that have like written maybe dozens. But that's really cool to be able to see the summary table and like get that curiosity that I wouldn't have without the exploration tool.
Let me see. I'm going to comment out some of these ones too, I think. Let's see.
Yeah, because aren't we drawing like tens of thousands of elements for every one of these?
I think each of these has like 100,000 elements in it, because
I thought they were Canvas.
No, they're SVG.
Oh, okay.
And yeah, there's like 81,000 rows in this data set. So that's a lot.
We did pretty good though. Like, you know.
Let's see. So what we were going to plot, we wanted to understand sort of how active each of these, or how prolific each of these authors are, right?
Yeah.
So I think we can do that. Let me just pick a spot here. So plot.plot. And we want to do
they would be bars, right? Because they're not necessarily ordinal, but they are.
I think this is like, my first take would be we're considering it, again, thinking of the data, like we're looking at a one-dimensional distribution, right? Which is like, if each author has a count of stories that they're interested in, or that they've written. And so we need to kind of group all the data by author, and then we're just plotting sort of the count of stories for each of those authors. So that's a one-dimensional distribution. And because author is an ordinal dimension, we would use the group transform. And so remember the first thing we looked at when we were looking at the reviews distribution, we used like the tick. So I think we could do like a rule X actually. So that would be data. And then we said like plot.group. I think we just use plot group here.
You don't have to do group Y?
I'm thinking for a second. So let me see. So, or is it group X? Maybe it's group X. Anyway, we'll find out shortly if I was correct. So X is going to be, actually, like we're grouping all of the authors, right?
Yeah. Yes. Yes.
I think it's actually like this.
Z. Interesting.
Hold on, I'm thinking for a second. So, and then the output is going to be, it's a count, right?
Yes.
So X is a count. Okay, so I think actually it is X. Something like that, maybe.
At this point,
apparently that worked.
Wait, but then it's saying author, that the x-axis is both author, but then the ticks are saying quantitative.
I think that it's like count for each author. So this is just like this field getting passed through, I think. Because we're telling it to compute the count.
So the question I have here, and I'm just curious about your thought process, is earlier when you did the rule, that made sense to me because it was an easier step than trying to group it at first. But because you're already grouping, wouldn't it be just one step away from just like swapping that rule X with the bar Y, and we would get a histogram?
Let's see. So, well, we need to do some binning in order to do those bars, right? Because this is still drawing one. In this case, it's drawing a rule for each author. Like we can also draw dots. So each of these dots represents an individual author. And then their X position represents the number of stories that author has written. So if we wanted to convert this into a histogram, we need to do the binning on top of that grouping. So we need to first group and then bin. So, and I think that's possible.
Right.
You'd say like plot.bin, and X, I guess. And then you would say, what would you say here? Or you pass in,
wait, sorry. I thought it was simpler than that. Because I thought it would, okay, so because earlier you said anything ordinal, we use bars, and then bar is to group as rect is to bin. So then, okay. I'm going to shut up because it worked.
Well, no, I don't think this is actually showing what it's supposed to be showing here. I'm trying to think through, probably like missing something. I think there is a way to compose these things, but I'm kind of like blanking on it because, you know, I'm on a live stream. But like, you know, so there's the longhand way of doing this is like, you would say, you know, D3 group data, and then you would say, well, I guess like roll up or something like that. So we want to count the length for each of the authors, something like that. And so this is basically like, this is the author's name, and then this is the number of stories that they've written. So you can do, or you can do it as an array like that. So we could say like, you know, plot.plot of that. And so that would be Mark's. And then this would kind of get us back to, let's see what we had. So X is, actually, I don't even think you need, I think you can just do that. Well, actually, so what are we're plotting, X is the author name and Y is the number of points. So we actually wanted a one-dimensional distribution here again. So that would be like, let's see, I don't know if there's like a shorthand, but it's like X is, well, 0 because that's, or sorry, 1, I guess that's the second field of the array that's returned. And then Y is undefined. So that's a little funky, but basically like this is an array like we saw before, an array of arrays. Where the first element in that array is the author name and the second element is the number of stories that they've written. So I've written it, you know, as a string shorthand, but you could also think of it as like author count here. And then we want the X position of these dots to be the count. So we're doing it like that. And then we're saying the Y is undefined, which I don't think is actually necessary. Yeah, so you can just do it like that. So this is like a one-dimensional scatter plot.
I think I'm finally understanding.
Yeah. So then with this one, we could take now a rect, and then we can definitely do like plot.bin X here. Then we would say sort of a count of counts or something. And I think this is probably getting the same, let's see, so X is, or sorry, Y is count. Yeah. Oh, so that actually was correct. I think so. Is that right? Let's see. We're saying that there's like 24,000 authors that have just written one. Yeah, which kind of makes sense. So if I filter that.
I just realized the difference in my thought process from yours, because the reason why in my mind it was much simpler was because I was thinking of it as a bar chart instead of a histogram, and the bar chart where the x-axis is the author's name and the y-axis is then actually, so it wouldn't have even needed a bin.
And that,
Yeah.
And
That's kind of, yeah. and that's why I realized mine was so much simpler in my head than what you were doing, and I finally realized what you were doing.
Yeah, because it's like we're doing this, we're trying to understand a distribution, a one-dimensional distribution of like, how, another way to think about it is like, how many fan fiction stories are these authors likely to write or are likely to have written?
Yes, you're right. And that's why and that's why you had a two-step process where you first grouped all of the stories by I'm just trying to now summarize.
Yeah.
So you first grouped all of the stories by the author name. So then you and then that was where you did that was the equivalent of the roll-up. And you got the author and the number of stories. Then you took that and you binned that. Actually, and then you binned that because now you're interested in seeing the histogram where you count up. And then the x-axis is the number of stories per author, and then the y-axis is the count of that. I don't think my summary was that great, but just trying to summarize what you did. Yeah.
Let's see. It's again one of those like exponential distributions where most of your authors have only one story. So was it before that we did this? Like if we just wanted to do
I just
like
tried it
0 to 20.
below. Oh, I guess it's much quicker to do it that way. Just cut off. I just copied what we did earlier and like did the value domain.
Oh, cool.
It's harder to read.
Oh yeah, I think you can do that still here.
I tried it there and it's
a little bit convoluted. Yeah.
I like the scale one. I mean, in terms of speed, right? Like if you're going through and you're just like, oh, I just want to cut off everything that I don't want to see, what I don't care about. It's kind of interesting how easily you can do that with plot and then bring it back.
Let me see. So this would be like X is value is group.x, and then domain is 0, 20, something like that. Yeah, so that's the other way that you would do it. So it's a little weird when you're like composing these things because like you don't have like the channel names exposed, like the X and Y and that sort of stuff. And remember, we did this before where it's like if you're using bin, often that X value is just the value, like the name of the column that you want to bin on. In this case, it's a derived column though, because that column is something that came out of this group operator. So what I'm doing here is, just treating them like objects and pulling out the group.x so that I can then pass in that domain option. And I'm not even sure if we need to like splat in everything else there. Probably. Okay, maybe we do. There's some other options in there or whatever that are getting passed through. Oh yeah, like the transform option. Yeah, so there's other things in there.
I also just realized another one of my confusion was in your first line and you say group X and then you're saying that you want as input the author. So you're saying X author. And then as your output, you're almost overriding that with X count. The X and X part was what confused me.
Well, this
also
is like the inputs and the outputs. So this is like your inputs where you have this data set and one of the dimensions of that data is this ordinal dimension called author. And what we're doing is we're converting that into a quantitative dimension, which is the count.
So does that mean that in this particular case, like because you're only using that group as transform, that you could have said Y count, Z count, whatever, and then as long as in the recti that line, as long as you had where you have X value group.x, if you said group.y or group.z, like it would have been the same?
I think so. Yeah,
Yeah.
the group X and group Y, like there are other aspects of it, because like when you're doing, like when there's subgroups, basically, like when you have a scatter plot and you want to group it, but then you also want to like subdivide those dots by color, like when you have multiple ordinal dimensions that you're dealing with, there's kind of some different variants of it.
Got it.
The other thing that I'm noticing here that's a little weird is like, we know that these are counts. Like you can't have written 1.5 stories. You can only have written 1 or 2 stories. But the default behavior for bin doesn't understand that. So it's generating these like 1.5 to 2 bins that are always empty, which is why there are these gaps here. So we could do like one way to do that would be to just kind of like reduce the number of bins here. Or maybe like 20 would actually work. Yeah, so that's better. So now it's like they're not these gaps between the bins. And also like we know that there's nobody in this data set that's written 0 stories because they wouldn't be included. So, oh yeah, why is that there? We can get rid of that. So now it just starts at 1 rather than starting at 0. So that's a little better.
Awesome.
And we could do the same thing we did before also, like where we counted the reviews, right? So like, let's see. So
yeah.
X, like sum the reviews or something.
Oh no, that starts to get complicated. I've lost it.
That would be that would be how many? So authors that have gotten how many reviews? Wait, why?
Oh yeah, no, we can do that. You're right.
Right, it would be.
No, so this one has to be.
Oh wait, sorry. This count and then review. Wait, no, author and then. Wait, author here. Count that. Oh,
No,
I see. I see where the complexity
so I think it
would
has to be. This has to be a sum.
Of the number of reviews per story.
Once you do group Y or something like that, where it's like you're summing Y over X, or sorry, it's group X of.
Yeah, so that's it, I think. No, is that right? What are we plotting here?
I'm going to take out the domain.
We wanted to say like what is like the total number of reviews for each author, right?
And that makes sense actually, because this plot makes sense because then there's only one author that's up here in the 10,000s. And then most of them are down here. So if we say that the domain is 1 to 2,000, then this is,
because these are again, we're back in that sort of long tail thing where there's a huge number of authors that have written one story that got very few reviews.
Yeah.
This is the inequality of Harry Potter fan fiction authors.
So this is really interesting. I feel like right now I feel like I'm reading Mike's code in real, like this is what's happening. I'm like reading D3 code in real time, being like, I don't know what's going on here. But you added in this, you basically shifted the author to the Z dimension, added X reviews, and then it magically worked.
Yeah. So here's the thought process. Okay. So before up here, we did like group X, and X was count and X was author. So we were grouping by this X dimension, which is ordinal. And we wanted to output a quantitative dimension, which was count, which we were, first we used to do the dots up here, and then we binned it so that we could get this nice histogram. Now, with the count output, so this count, this word here, count, is not like this word. So this word is referring to a dimension in your data. You could also write this as an accessor, right? Like d.author, like we were doing before. And there's some other ways that you can write those sort of things. This is not like that in the sense that like it's specifying a named reducer, which is kind of a strategy for taking, a set of values and returning a single value that kind of summarizes that. So
and we can also pass in an accessor there, right? Because then you would get an array of data and you might count those or sum those.
Yeah, exactly. And this is like described kind of in more detail here as these like aggregation methods. So we were passing in count, as the first option. And what you were describing is like passing in a function here. And there are these other reducers as well. And in particular, like the one that we're talking about now is like doing a sum of values. Now, the thing about count is that like count doesn't require a dimension as input. And what I mean by that is like, you have, like if you compare count to sum, like if you're saying count of elements, you're saying like count of rows in your data set, whereas you're saying sum, you can't sum rows themselves because rows have multiple columns in them. So you have to be like sum of what value for each row. In addition to saying how to reduce it, you also have to say what's being reduced, like how to assign a value for each of those rows. So that's why in the case of like when you want to sum something, you have to tell it what you're summing. And in this case, we're summing the number of reviews. Okay, so before, we could say we were counting the number of authors, but each author sort of implicitly counts as one, like, each story counts as one. So we don't need like another way of telling it what the value is that's being summed if it's just counting. So the problem is like we kind of wanted to say like X reviews and X author here because like X is meaning two things. One is how we're grouping it. And then the second is like what is the sort of input to this sum reducer to tell it how to sum the value of each rows. And since we can't, have two X's here, I'm using Z as this other dimension to do the group by. So it's like grouping by author and then taking out the reviews column and then computing the sum of that.
Got it.
So I don't think you actually need the group X here. I think you can just do group. Okay, maybe it doesn't work. There's something else that's going on here, but
something I just tried below that helps me a little bit because this is
I just went backwards.
Whoa.
I can.
This is my magic mouse.
Real quick. So basically, the other, like the whole, there's two X's we want to think about. Like, all I did was switch to doing the output on the Y, and then leaving the X as author. And then over here, I did have to say group.y to grab that output. But this is how I'm used to doing like a sort of summing on one channel and grouping on the other. So that's
So I think all of this time, what I was trying to understand is that it almost seems like plot is smart enough that like it doesn't quite matter in the inputs or options part if I like which order I give the X or Y or if I use Z. Like plot is smart enough to be like, oh, this is a sum, so I need two dimensions in the inputs, and let me go grab those. And one probably needs to be discrete, or one needs to be ordinal and one needs to be a quantitative dimension, etc. So the reason why I was trying to understand this is because sometimes I'm like, do I need to pass in, X and Y in like a very specific way? But it seems like I don't need to. That plot knows what to do as long as that as long as the the Y sum and the Y reviews part is matching up, or does that not even need to match up?
So this, well, first we're like a little bit over time, so I want to be respectful to everybody that's watching. But I think to answer that question, like the smartness of plot, I think is mostly in terms of, I guess like ambiguous or like overloaded syntax and defaults. So remember, like, one of the goals of plot is to do, fast exploratory visualization. And part of that is, the abstraction, like having concepts that fit the task well. Like, you don't have to worry about how the scales are constructed. Plot will do that for you automatically. But another aspect of that is a little bit more superficial, which is the syntax itself, sort of how many words do you need to write? How many characters do you need to type in order to express that idea? And the idea is like there are ways we could make plot smaller, like more concise, but there's a trade-off, which is that it becomes harder to understand. So we're kind of try to straddle this or find the sweet spot where it's concise, but it also has like, some rules, some consistency to it, some predictability. And that predictability or what those rules are not going to be obvious to new users. Like it's something that you kind of have to learn over time by familiarizing yourself with how these transforms work. And we did definitely try to make, group behave similarly to bin, behave similarly to, the window transform and other things like that. So that once you kind of understand, oh, this is how a transform works in plot, like you can take that understanding of one specific transform and apply it to the other transforms as well. So, but they are like, they're subtle and, like I get confused sometimes about like what exactly is going on. But there are some rules that hopefully, like, as you spend more time playing with it, you start to internalize it and be better at predicting, how plot is going to interpret it.
Awesome. Well, I mean, I think that both Shirley and I could keep asking you questions all day, but
I'm like restraining myself.
People would keep watching.
I saw the outline of this live stream and that was going to go through 3 data sets. And I didn't say it, but I was like, I don't think there's any chance that we're going to get through all 3 data sets today. But yeah, this is a lot of fun.
Yeah, no, this was great because I mean, we get to see in one data set, like I'm not counting how many plots this is, but like, right, like the real process of exploring, understanding, and then, it would be the next step to go and take that understanding and design. Well, surely you can tell us how much work it takes to go even further and make a book like this, this beautiful. But yeah, I mean, this is awesome. I think one thing I'd like to point out a couple of things that I liked seeing, Mike, as you're working, was like they kept copy pasting cells, right? Like something that plot was designed to work in a reactive notebook like observable, and you can kind of see that like as we asked questions, we got some answered, we saw some things, and then we kept getting new questions, and then we kept seeing new stuff. And at the end of the day, right, if you go back and watch the recording or you scroll through this and see like all the things that we thought about are captured here, and like we got to go deeper and deeper. And I think that's part of why we didn't get to go to the other projects, was because like it was so easy to just keep exploring, right, and keep learning. So I think that that's something really exciting and a really compelling reason to get familiar with plot. And yeah.
It makes me think we need a button to duplicate the current cell that you're in.
Yeah, I definitely Control-C, Control-V all day long. Yeah.
Yeah, and I think for me, I knew we were not gonna get all 3 data sets. I thought maybe we would get through 2, but I think as soon as we got into it, the part I started appreciating is like just being able to ask Mike all of these questions about like how to think about D3 and how to think about plot. I think that's what I appreciated the most from the stream, which is like, I went into it thinking that we were going to be like, look at how much faster it is to do things in plot versus me like doing this equivalent thing for a day, which is true. And I think we showed that. But I think the reason why, like in addition to all of the new exploration we got to do that I never got to do in the book for the projects, I just really appreciated being like, how do I think about this? And then Mike explaining everything. That was invaluable for me.
Yeah, thanks for highlighting that, Shirley. That's strong +1 for me as well. I think I touched on it a little bit earlier, but I do think, it's not just about kind of the speed. It really changes your thought process, changes what you look at, changes your understanding of the data. And we didn't exactly recreate any of your work, but we were able to learn some interesting things about Harry Potter fan fiction.
Did anybody need that? I don't know. But
well, I know what I'm doing after work today is reading Still Delicate. There's one thing I took away from today's stream.
I actually can't really remember that story anymore. Oh my God, I think it had to do with teenage pregnancy. I think.
Wow. The power of data visualization.
Yeah. But I think it covered it in a very like sensitive way. I think that's why it had like such good. This was, I think, around the time when like teen pregnancies was like a huge thing on TV shows. And I think it like, I think that story actually covered it in like a very realistic way. Anyways, yeah, I super appreciate. I don't think I was just gonna say like another redundant +1 to what Mike was saying about using plot as a way to really think through your data. That's something I didn't know before this stream.
Nice.
Awesome.
Well, we are past the scheduled time, and I do really want to thank both you, Shirley, and Mike for coming on and exploring in this way. I'd like to just take the last second to remind folks that we have a bunch more streams coming up tomorrow with the Observable CEO and co-founder, Melody McFessel, talking about Observable. Friday, Anj and I are going to do some more live coding exploring, and you can see some more events next week with some starter points for APIs and for DataViz. And then with all this, we're actually doing a fun little contest, calling it Fork to Win. We can go and fork some notebooks by sometime next week. It's on our Twitter, I believe. And we'll send you some, there's some cool prizes for that. And finally, if you do not have it already, you should totally get data sketches. Let me
thank
put
you.
that up here, because you could learn even more and enjoy the beautiful visualizations. So
thank you. I love NT Hit's comment. I totally forgot about this, but they said you got to read Delicate first. Still Delicate is the sequel, isn't it? And I just remembered that is true. And I think the second highest most reviewed is Delicate, which is the prequel, or I mean the first one. I forgot about this.
Yeah, it shows up in the data too. Nice.
Oh yeah, you're right. The 8,000 one is the, yeah.
Yeah. All right. Well, with that, everyone has their homework. You're either going to go read some fan fiction or data sketches.
Please read the data sketches, not the fan fiction. Embarrassing teenage years.
If you're, past the awkward teenage phase, we can read data sketches. Nice. And we have some people in the chat who just got the book.
Thank you so much.
Love it. So, all right. Thank you both. And we'll see everyone at the next stream then.
Thank you so much for having me.
Thank you. That was a blast.
Yeah.
Bye.
Bye.